Lesson 1-3. This lesson is about checking your answer to see if it is reasonable. In lesson 3, on page 10, to check to see if the answer makes sense. And that's really important to be able to do, to look at the numbers, to use estimation, and to understand what the numbers mean in order to see if your answer makes sense. So we do that by estimating first, and then finding the actual answer, or what we think the actual answer is, and then comparing the two. Let's look at the example. Follow along with the example on page 10. People in the United States eat 17 billion quarts of popcorn annually. That means every year. An average of 54 quarts per person each year. At that average, Karen and Noah want to know the total amount of popcorn students in their school would eat in 1 year. The school has 1,200 students. So, based on that problem, 54 is given to us, and 1,200 is given to us, and 17 billion. Those are the numbers that are given to us in the problem. How do we use those numbers to solve this problem? What is 54? What do we have to know about each of these? Or what else do we have to know? You can't just look at the digits, but...
We don't need 17 billion, because that's in all of America.
Okay, that's in all of America, so we don't need that number. What do we need?
It's actually 7 billion people.
17 billion quarts of popcorn, right. 17 billion refers to the number, the total number of quarts of popcorn. What is the 54? What does that number mean in the problem? What's the label behind it? What's the label behind it? 54 quarts. So I'm going to use QTS because that is the abbreviation for quarts that we use. A quart is about, let's see, well, it's 1/4 of a gallon. It is about the size of a big water bottle. Maybe this is about half a quart. So about 2 of these would be a quart. Okay. So that's the amount we're talking about. But this is quarts. We're missing something yet.
Per person?
Per person. Per year. And what is the 1,200? How is the 1,200 going to help us? Jack? 1,200 students. And what is our answer statement? When we are finding an answer, what we want to do is put it into a statement that answers the question. Okay? So go back and read the problem at the end. What is it that she's trying to find? Somebody read that part of the problem. What is it that she's trying to find? Or that they are trying to find? The 2 students. Johnny?
Want to know the total on average. Karen and Noah want to know the total amount of popcorn students in their school will eat in 1 year.
So we could write their school eats, and then that's how much we're looking for, right? Eats blank quarts of popcorn every year. Or per year. That's what this word per means, for every 1 year. Their school, or their students in their school eats blank quarts of popcorn per year. Now, how would we find the answer?
Multiply 54 times 1,200.
Good. We're going to use multiplication because for every student, they eat 54 quarts, according to the research. All right? Now, let's go back and how can we get a quick answer? What is the answer going to be approximately? What could we do to find a quick answer? If we didn't need to know an exact answer, then we could estimate. So what would we do to estimate it? Instead of 54, we could use what number? Okay? 50. And instead of 1,200, we could use 1,000. Or we could just use 1,200, because we could multiply 12 times 50. That would give us a better estimate, wouldn't it? Which one do you want to use? Tyler?
1,200.
Let's use the 12. Good idea. We're 6th graders now. We can handle 12 times 5. What's 12 times 5? Raiden?
I know it. 60.
60. Then what do we do with the zeros?
Add.
Not add them, but Nate?
Put them on to the 60.
Put them on to the answer. 3 more zeros. 60,000 what? Quarts. So that's our estimate. Now, let's find the actual answer. Peter?
I have the answer.
Okay.
So should I say the answer or no?
Yeah, go ahead.
64,800.
64,800. Now let's do the math and see. So we've got 0, 0, 8, 4, because 4 times each of the numbers, right? Everybody with me?
Yeah.
And then 5 times each of the numbers.
0.
Hold the place. Then 0, 0,
10.
10, and 6. And Peter's right. 64,800. Add the digits. Now, what does it mean to check this answer for reasonableness? What does it mean to check this answer for reasonableness? Is this a reasonable answer?
Yes.
Is this a reasonable answer? How do you know?
If we times the problem.
Well, is it close to our estimate?
Yeah.
Yeah.
Do these numbers match?
Yeah.
Yeah. So we can use both numbers as a way of checking our answer. All right? If this one said 600,000 and this one said 64,800, then you may have done something wrong. Maybe you put too many zeros in your estimate. Or if this one said 60,000 and this one said 6,480, then you maybe did not hold the place correctly when you were multiplying. So you're finding mistakes. If both numbers are close to each other, then it's a way of checking your answer. Okay? That makes sense, right?
Yes.
So reasonableness is using an estimate to check your answer. And using the estimate first to kind of check and see if you are on the right track. Okay? I want you to practice a couple of these for tomorrow.
Are you doing a quiz?
Nope. But you should turn to the correct page.
I turned the page.
What I want you to do is number 1 on page 11,
No assignment?
number 2 on your assignment, number 1, number 2, and number 3. 1, 2, and 3.